So in this presentation, I will be talking about implementation of neural networks using toolbox, MATLAB toolbox. The content of the presentation is on the similar lines like what you saw yesterday. So first, I will be discussing about this back propagation neural network algorithm. Then I will take one very simple example. Then I will implement it using MATLAB toolbox, and then I will be talking about a case study which I performed in the past. So takeaway from this session is, after attending this session, you should be able to create your own neural network models for your applications. So what is artificial neural network? So basically it is a biologically inspired computational modeling technique. So scientists try to mimic, they try to predict what is happening inside human brain. So, and they assume that such kind of complex network is there. And the dots which you see, they say it is a neuron, and neurons are connected with each other. And this is simply a perception. Just they try to mimic. They try to assume this might be happening inside the human brain, which is very difficult to predict what actually goes inside that. So inspired by this design, they are creating this algorithm. So neural networks, so why to use neural networks? Every evolutionary algorithm is having salient features. They are good at certain activities, and they almost all of them have certain drawbacks also. Like fuzzy logic is, they are good at decision making. Neural networks are good at learning. Whenever you want to give data and you want to create model, you want machine to learn, then neural network is good at it. If you want to perform optimization, then genetic algorithm is a solution for that. So the good part is, in neural networks, they are best whenever you have huge data, lot of data, and you want to make a machine learn. And then they are fault tolerant also. So they are quite robust. Even if there is some data missing, they will give accurate predictions. So that is fault tolerant. So when we talk about neural networks, there are two approaches. One is supervised learning, another one is unsupervised learning. So there are two approaches. Now what is supervised learning? In supervised learning, I know what is the input and I know what is the output. So input and output is known to me, and I create a model using neural network. For example, I want machine to tell me what is inside this basket. So in supervised learning, what we do, I will take a picture of, say, apple. Then I will tell machine that this is the apple. If this is the size, this is the color, this is the shape, this belongs to apple category. Then for banana, same way I can perform same thing. And this is like, I know inputs, and for this input, these set of inputs, this is the output. So I am training it. Now once the model is trained, when I provide this basket, it will be able to tell me what is which fruit. So this is like supervised. So supervised learning. I have inputs and I am having outputs. So mapping of input and output is done using neural network. Supervised learning. Second is unsupervised learning. Here you have data with you, but there is no output. So when you don't have any output, how to create network? Then the algorithm will try to find out similarities. What are the similarities here, and what are the differences? Accordingly, they will categorize. They'll put in two categories. For example, so I give this picture to machine. Machine will find out, so something having 4 projections, say 4 legs. So anything which is having 4 legs, so all of these have 4 legs. So one set you have. if I put a picture of a person here, human being here, so it is different from these. So it can be easily recognized that something is different. So that is the meaning of similarities, patterns, and differences. So unsupervised learning. Coming to back propagation neural network algorithm, this belongs to which category? This belongs to the first category, supervised learning. I have input and I am also having outputs. I am having inputs and outputs. Now I have to create a network. So the structure looks like this. So here, this is the first layer which is having inputs. Middle layer is hidden layer, and the third is output layer. So you have input layer, hidden layer, and the output layer. So first layer, hidden layer, and the output layer. So back propagation, it is an iterative process. For this, creating such kind of model, you should have data set with you, huge data. You should have inputs, and I should also have the outputs. Then only you will be able to apply backpropagation neural network. Now these nodes, they are represented, they are called here neurons, because it is inspired by human brain. So these are called neurons or nodes. Now here, suppose this is my input, talking about mechanical domain or machining. So this could be speed, feed, depth of cut, my three inputs. The outputs could be cutting forces, tool wear, vibration, so on and so forth. Now this is my input. I give input. From this neuron there is a network. Some data, some part of this input will go to hidden layer, some part will go here, some part of this input will go here to the second neuron in the hidden layer, some part will go here, and some part will go here. So this part which is moving from here to here, it is going with certain weight. So some input here, it will go from here to here with certain weight. What are weight and what are other things we will be discussing shortly. For the time being, input, I give input here. This input will be distributed to this using certain weight. So here you have 100%, some portion goes here, some portion goes here, some portion goes here, and some portion goes here. Exactly same thing happens here. The output from here goes to the next neuron in the form of a weight. So you have a weight here. Some portion will go here, some here, and some here. So from one layer to second layer, you have weights, and in this layer, in this hidden layer, you have a bias. In the output layer also you have a bias. So bias is not dependent upon the output from the previous neurons, output from the previous layers. Here on this, if you see on these neurons, so everything is dependent upon the output of the previous neurons from the previous layer. Whereas bias we are adding here, you have one bias at the hidden layer and one bias at the output layer. Okay, so you give the input, this is created, and you get the output. Now how this weights and biases are selected? Initially the algorithm will begin, it will assign these at random. Any bias, so any weight and any bias, it will start with like that. So at random it will be assigning weights and biases. Now this network is ready, you have input and you will see output. So when biases and weights are decided at random, obviously you will not get perfect solution. So you will have a huge difference here. The output which you will get here and the output which you are expecting to get. So there will be a lot of difference. So that error you will find out. How much is the error here? Whatever error you get here, that error you will divide it in the previous layers. You will be changing the error which is here, you will be dividing it in the previous layers through the weights and the biases. So we'll divide my error, go back to the previous layers and distribute my error by changing the weights and biases. So that is why it's called back propagation. Whatever error I have here at the output, I will be back propagating it. So that error is back propagated. This is first iteration. Then second iteration in the forward pass, again we'll start from left to right. Again we'll check what is the error. That error is given back to the weights and biases are changed. So this process is iterative process. It will be repeated till we get the good solution. Good solution, meaning of good solution is I should be able to get the error within the permissible limits which I set for my application. So algorithm. So this is what is there, the algorithm. I'll be talking about algorithm. I assume there are, so this is input layer, this is hidden layer, and this is the output layer. Input, hidden, output. So this one input I am denoting by I. This layer I am J. This layer is K. I, J, K. So I, J, K, 3 layers. So initially we start with the weights and biases are at random. The algorithm will start like this. Initialize all weights and biases. Second step is, so I am giving input here. I want to see what is the output here. So here OI is here. So what is the output here? So output here is whatever you give the input, that is the output here. Nothing is happening here in this neuron for the first layer. So whatever is the input, that will come here. From here it will go to next layer. From first layer it will go to the next layer. What is happening in input in the hidden layer? In hidden layer I am having some input and some output. So what is the input? So I is input, O is the output of jth layer, the hidden layer. In I layer nothing is happening. Whatever is the input, that is taken as it is. In jth layer, so here what will happen? So whatever is the output here, so say OI is the output here, it will be multiplied by the weight plus the bias. Weight multiplied by the output of this, and the weight is added. So this is my input here at the hidden layer. Input to this neuron. Input of this neuron is weight multiplied by the output of this plus the bias which I have on this layer. So this is my input. So what is the output? So output, for output, this is the function. For output I am using sigmoid activation function. This is called sigmoid activation function. Activation function means it will give output with a certain formula. So that formula is here. So this is the formula for having the output from this neuron. Output from this neuron I will have using this formula, and this equation is sigmoid. So this one. So you can have many different types of activation functions, but to be moderator, if you compare it with this one, here you are going from 0 to 1 abruptly. Here slowly we are going from 1 to 0 in a gradual manner. So this is most of the time. So this is the most of the time you'll find they are using sigmoid activation function to have output from any neuron. So here, so there are two things. One is input. So input, and second is the output. Input is this the input from the previous layer multiplied by the weight plus the bias here, and the output of this is governed by this activation function. OJ is 1 upon 1 plus e raised to power minus ij. So ij we have obtained here. So this is the output from the this neuron. Output from this neuron. Exactly same thing is happening at the output layer. So output layer will have input. The output, this one, what is the input here? I say it is input here is dependent upon this one, the output which I get here, output from here, output of J, multiplied by the weight which I have here, plus the bias which I have. To have the output from here, again we are using same activation function, sigmoid activation function. So ik we have already computed, so you can put it here in order to have the output from this neuron. So each neuron will have input and the output. Output is governed by some activation function. Is it all right up to this point? Now next step is to calculate error. Calculate error and distribute it backwards. So there are only two steps. Go forward step, get the output, and now I will calculate what is the error. Whatever is the error at each layer, I will distribute that error backwards. So these are the formulas for distributing error backwards. By changing, you can change the weights. In order to change the weights, you also have one factor which is called eta. Eta is a learning rate, which is used. So you will update weights and you will also update biases. So both these are updated, and you again do forward pass. So this is an iterative process. Say in 400, 500 passes, you are able to achieve the error level which you have fixed for this setup. So once you get that, you say your model is ready for any prediction. Simple example, very simple example. In this simple example, we are taking only two inputs and two outputs. So x1, x2, these are two inputs. y1, y2 are my outputs. b1 is bias in the hidden layer, b2 is the bias at the output layer. So what I will get here at h1, what I will get at h1, at any neuron, I will have input and output. So h1, so what will be the h1 here? So it is x1. So h1 is having input from x1 multiplied by this weight w1, and this is also having input from here, so x2 multiplied by this w2 plus the bias. Same way, when you see what is you are getting at h2, same thing will happen. Like h2 is having input from here, this input multiplied by w4, this input multiplied by w3, you get h2 plus the bias. Now in order to have output from here, so you require activation function which is sigmoid, and this is the equation for that. So h1 you have calculated, and now you will place h1 here, so you get the output. So now it's I'm taking the values. So input x1 is 0.05, x2 is 0.10, and this is the target 0.1, p2 0.99. Input and output is known to me. So this is known. Rest everything is, so first step is to initialize the weights and biases, which is done at random. So at randomly any value is taken. Biases are selected b1, b2. These are the weights. At random weights are selected. Now using these equations, we are finding out h1. Using activation function, we are finding out the output here. So output of h1 is obtained. Similarly, output of h2 is obtained. Now we want to calculate y1 and y2. Again, the formulas are same. The y1 will have input and the output. So input of y1 is dependent upon the output of h1 multiplied by w5, which is here, and it is also having the output of h2 multiplied by w6 plus the bias which you have here, b2. So using this, and you know the values, so you put it here, you get y1. On the similar lines, yes, so this is input. In order to have output from y1, you need activation function which is sigmoid, so you use it, you get this value. On the similar lines, you will calculate y2. So y1, y2 is calculated in the forward pass. Now it is time to calculate error and propagate it backwards. So for calculation of error, so we are using this formula. So target I know, and output. So target and output, difference between target what is expected and what actually I'm getting. So that I know. Now here E total means total error. E total means error here and error here. So that is why target is known. This is my target, and what actually I'm getting. So output of Y1. Similarly, so it is one. So it is half, like E1 error 1. Error 1 is here. Error 2 is here. Okay, two errors. Okay. So we are joining them. Total error is error here and the error here. So that error we calculate. Okay. So these values we have calculated in the previous slide. Target, I know what is the target. So whatever is the difference, from there I will calculate total error. Is it okay? Now for updating weights, I have to update the weights. In order to update weight, so first I want to update the weight at W5. So in order to update this weight, I will be using partial derivatives. Error at W5, this is the total error, del E by del W5. So this is the total error with respect to, I have to find out here what is the error. Total error is here, so I have to distribute. So there are so I have to distribute it everywhere, W5, W7, W6. So I have to distribute that error. In order to distribute it, so you will distribute using this equation, using partial derivatives. And when you see this partial derivative, this is my total error is here. In this total error, there is no W5. So you don't have any W5 here. So you cannot perform derivation. So you cannot perform derivative. So what you do, when you cannot, you don't have in this E, you don't have W5. So what you will do? So you will split it in multiple terms like this. Okay. So you split it in 3 terms like this. So here I am having in Y1 I have W5. In Y1 I have W5. Okay. So when you put all these 3 terms, so this will be cutting with this will be cutting with this. So actually you can do like this. So you are splitting in multiple terms. This you know how to do it. So from here, so now you will calculate each term. This term you will calculate this term, you will calculate this term. And then once you have calculated each of these terms, then you finally put it together, and this is the total error which with respect to partial derivative of total error with respect to W5. This is the error which you get, okay, here, which I will be putting. I want to change the weight. The goal is I want to change the weight. For changing, I want to update the weight, and this is the formula W5. W5 is the initial weight minus eta into the partial derivative of the total error with respect to W5. Eta is the learning rate. You can have value from 0 to 1. For the time being, I am taking 0.5. So when you place it here, and this is your updated weight now. So now for the second pass, for the second iteration, this will be my updated weight. On the similar lines, you will calculate weights for W6, W7, W8. Following the same steps, you will calculate weights. You will again change weights. You will update weights for W1, W2, W3. Exactly same steps are followed for calculating, updating the weights. Okay, so this is the iterative process. In one pass, go back, change the things, again second pass. So number of passes. Still, when you stop, you can stop. You can, like yesterday, professor was talking that you can stop when your network converges to a certain level. You can either fix number of iterations, or you can fix error level. That if this is the error level is up to this point, it is acceptable. So I can use this model for my application. So next step is to implement it on MATLAB using Toolbox. Of course, the best technique is to use programs. ultimately here also you will see that we will be coming up to the programming. How many of you have used neural networks using this toolbox? How many of you? Okay. So what you do, so you open MATLAB. So here for in this modeling, if you see what you are giving input and output. That's it. Nothing is required. All these models are data driven models. You cannot enter your equations into it. So it is simply mapping of input and output. You cannot write your own equations into it. Okay. So in order to give input, so what I can do, you can give input like this. So input is a variable. On the command line itself, you can write the variables in square parentheses. Whatever you write in square parentheses, it is like a matrix. It is like a matrix. Same way, this is the output. This also you can write like this. Or in MATLAB, you have a feature, you can take values directly from Excel also. You can import all those here with just one command. It will read all those files. Now you start N start, neural network start. So you enter this, you come to this first slide, and from here you select fitting tool. You will get this on screen. So I will give a demonstration also, but it is not a live demonstration. I have recorded it. I try to be on the safer side. Okay, so this is the slide you get. So you here click next. So you come here next. So here it will ask you input and output. So input, the input variable, you have created input variable and you had created output variables. So here those variables will appear. They will be in memory. So when you click here, so you can load input. You click here, you will load your target, and then click on next. So when you go on next, here automatically whatever data it is there, it will be distributing that data in this form, say 70%, 15%, 15%. This is by default. You can change those values. Yesterday somebody was saying, like, you can change these values and you can try. It is possible. You can change the percentage here for training, validation and testing. So there are 3 data sets. Okay, so once you go through this, press next, come here next, it will ask number of neurons that you want to have in hidden layer, number of neurons. And then 10 is by default, you can change this value. Then press next. Here you will be training your model. Once you train that model, you can you can see the errors. So how your model is behaving to the data which you have provided to the system. So here you can see. So this is happening. This is what is happening with my training data. This is what is happening with my testing. This is what is happening with my validation data. And this is overall. So overall, it appears to be a good fit. Whereas for testing, so there are two separate lines. So it is not that good a fit. So what do I do? So I will go back. I will go back and I will go back and I will change number of neurons. Change number of neurons, again retrain it. So you will do this process number of times till you get the accuracy which you desire. Or if this doesn't work, then the next step is, so you require more data. So all these models are data driven models. So the more the data, more accurate your model is. A case study which I did in past. So here, so we try to estimation of cutting forces and surface roughness during machining operation. So here we have input parameters are approach angle, speed, feed, depth of cut, and the output is cutting forces and surface roughness. Cutting forces and surface roughness. So we are doing experiments, have huge data with you, create a model, and then your model is ready to predict any real situation. So then we can compare what is happening. Now here we tried some optimization. So optimization, what I did, here, number of neurons, we played with the number of neurons. If I increase or decrease the number of neurons, so what happens? So initially I started with say 10 number of neurons, 10 number of neurons. Then what I did, initially I put 10 number of neurons and trained it and tested it. And when I performed training, the goal was, I also found how much time it is taking when it is 10 neurons and what accuracy I'm getting. Accuracy and time. Error and time. So how much is the error when there are 10 neurons, how much time it is taking for my model, for training. Then I increased it to 15, 20, 25, so I went up to 50. Trained it and found how much time it takes and how much is the error. Then I optimized it. For optimization, what condition we imposed, that within this range from 10 neurons to 50 neurons, and also number of epochs 100 to 500, when you get the best solution. What is the best solution? So from there we get the structure which we get is optimized structure. Otherwise, deciding number of neurons, it is an iterative process. So there has to be some method for optimizing the structure. So this is what we did for optimizing the structure in the number of neurons in the hidden layer. Number of its iteration. Basically, here it is called iterations. Number of iterations. Number of iterations. So this was a case study, and it was published in Journal of Intelligent Manufacturing in 2008. Probably this was that time. It was a new thing, so it is easy to publish when something is new. Whenever you are publishing something, say if I publish something today, in a span of 2 years, it becomes almost obsolete. Okay, but it doesn't mean that what I'm doing now is irrelevant. In 2 years, my knowledge expands. I go further. Even if I read my own articles, I'll feel that I should have done this, I should have done this. So my knowledge expands. So this is how we all progress. So it was relevant at that point of time. Still relevant. So thanks. Thank you very much. Any question you have, you can ask. Otherwise, I will show you how to demonstrate there. First, let me demonstrate. I'll play a video. So first thing is you open this MATLAB environment. So here give inputs. So give input in a matrix form. So I am using square brackets. If you want to give matrix, so you will use the square brackets. What? चलता नहीं बेगम देखिए वीडियो वाला वीडियो स्क्रीन तो नहीं आ रहा चेंज करना बना स्लाइड हाँ वही करना स्लाइड वही करना यार कि स्लाइड शेयर की कहते हैं स्क्रीन ऐसी और प्रोजेक्ट टू सेकंड स्क्रीन डुप्लीकेट ठीक है is it visible? बंद हो गया. So first is input. So first I will give input. So input you can have either directly also, you can have cut copy paste from Excel. So you are keeping it within the square parenthesis. So pasting it here, so you have your input is entered. Next step is you will give the output. So this is another variable name which I am creating, output. Again square parenthesis, because I'll be bringing data from my Excel file, selecting it there and pasting it here. So from this, the last one is my output. So this is I'm selecting and again bringing it here, output, pasting it. So now my input and output is in place. So you will start that toolbox, NN start. So this will appear. Next. So from here you will select input, first input, target is output, and these values we have stored. And then you need to click here, row, output should be in the matrix row. So here that training data 30%, 15% and 15%. Validation and training data you can change. So go to next. This is your structure now. So here you can see number of hidden neurons. Neurons in the hidden layer, train it. So when you train, so you can see the errors and then select on the plot regression. Yeah, you can see the errors. After that you can select on the plot regression. So you will see on screen how your data is, how your model is behaving with data for all the 3 sets and in total also. If you are not satisfied with the results, then you can train again. So you can retrain here. You can change the number of neurons. Say this time I'm changing to 20. Again train. So error should go down. So again I can see the plot. So I can import. If still it is not behaving as per my requirement, I can have larger data set with me. Next step is taking next. So here I can. So here you have option simple script. If you click on it, you will get everything in program form. So you have a program here. Whatever model you have created, you will get that program in that thing in program form. And it is advisable you should be using this one. So simple script. So this is the program. You can see this is the neural network program which is built for you as you worked out through this. And then you can once your model is ready, you can use it to predict real for real inputs. Okay. And so that's it for the time being. You can ask if you have a question in mind.